What's up, guys? Today we're going to be making a simple FPS controller in the Godot 4 beta. So let's just get right into it. First we need to make a new project. So you can name it whatever you want. I'm going to name it FPS tutorial. And then you have to choose a file location. We're going to use Vulkan clustered as the render since we're making a 3D project. And it's going to take a second to start up here. Alright, so first we need to make our world. So let's make a 3D scene and we're going to call it world. And we're going to add a floor. So we're going to add a mesh instance 3D, and this is going to be our ground. There's a whole bunch of meshes here, so choose a plane. So let's make this floor a bit bigger so we can actually walk around on it. Then we go up here to mesh right after this, and we're going to say create tri-mesh static body, and this is just going to generate the collider for us that matches the shape of this plane. And we're going to rename it ground. Now we're going to save the scene, and it's going to be our world. We need to make a new scene for our player, and we're going to add a character body 3D to this. I'm going to rename it player. Now let's add a mesh that's going to be like the body of the player. And we have a couple options here, but we're going to use a capsule mesh. As you can see, there's a capsule right there. So we go up here, and then we press create simplified convex collision sibling. It's just a simple shape, not many polygons. So now we're going to add a node 3D, and I'm going to call it head. This is just going to be our rotation object for our camera. So we're just going to add a camera inside of it. And that is our player scene setup, so we're going to save it. Then we're going to add a script to our player by pressing this little scroll icon with the plus. And we're going to change it to C# since we're doing it in C#. Turn off the template and save it. Create it. So now we have a C# file. We're gonna need to start with adding some variables to be able to control our player. So let's start off with a constant speed, float speed. We're going to set that to 5, and actually it looks like we're getting an error here. So we're going to need to go back into Godot and press build, and it's just going to create the project, the project solution for us. And now when we go back into our editor, it should work now, and it looks like it does. So you can see namespace Godot. So we're just going to continue adding some variables here. Let's add a constant float gravity, and we're just going to say it's like 30. Then we're going to make another variable, well, not variable actually, a constant float jump force. and we're going to make this about 5 or 10. I'll just go with 10. And we're going to make another constant. That's going to be a float. The acceleration. This is going to be used for slowing down our player later, so let's just set this to something like 0.5. And then finally, we're going to make a float that's going to be our sensitivity for when we're looking around with our mouse. And I'll set this to 0.01 because this is in radians and not degrees. Next, we're going to make a couple of variables for our head and our camera, because we're going to be applying rotations to each of these objects. So cam, I'm just going to change this to cam just to make it easier. We should probably set up some inputs, so go to project settings and input map, and we're going to create some new actions: up, left, down, and right, and jump. So we're going to add some bindings here for each of the keys. Alright, cool. Now this is just going to read our input, and we can access it through code. Now we're going to make a new function or method, and we're just going to use a built-in one called physics process, so we can move our player. Oh, and I almost forgot, we're going to make a private vector 3 called velocity, and we're going to set it to vector 3.0 so we can move around our player. Now we're going to make a new vector 3 called input dir for input direction, and we're going to say input.getVector, and this is a new method for Godot 4, and it just gets all the I guess actions or vectors for this. So we're going to put in our things here, and as you can see, it matches with the arguments for this method, because left is negative on the x-axis and forward is negative z. So we're going to make a new vector 3 called direction, and we're going to say global transform dot basis multiplied by a new vector 3, and we're going to input our input dir.x and input dir.y, and we need to normalize it so we don't go faster diagonally than we do going forward. And I may have said vector 3 input dir, but it's a vector 2, and this can't be negative, so there we go. Now we're going to make an if statement saying if direction does not equal vector 3.0, so we're saying if there is a direction and we're moving, we're going to say velocity.x equals direction.x times speed. Oops, I put input dir. So direction.x times speed, and we're going to do the same for velocity.z. We're going to set it to direction.z times speed. So now we're just saying that our velocity is our direction, and we're going to multiply that by our speed so we can move faster than 1. Alright, so now we need to instantiate our player into our world. And we can move him up a bit, although we don't have gravity yet. So let's save it. If we were to play this right now, there would be no lighting and it would all just be gray, so we need to add a sun and an environment. So now when we run this, we should be able to actually see stuff. So select the current scene, which is the world, and it's going to build the .NET project. And now if we try to move, it should work. So let's see. And it's not doing anything. Oh, okay, so I completely forgot, but character body 3D has a new built-in function, or not function, but like a value called velocity. And we need to set this new built-in value to our velocity that we defined by saying velocity equals our other velocity, which is our variable. And we also need to use move and slide. And as you can see, we're not putting anything into it because it uses our velocity. So if we run this now, we should move. And yep. But as you can see, if we press a key and then release it, we just keep going in that direction. So in order to fix that, we have to say else velocity dot x equals math f dot move toward the built-in velocity dot x 0 and by our acceleration. And we need to do that for the z as well. So I'm just going to change that to the z. And as you can see, the acceleration is just what our velocity is multiplied by until it reaches the value of 0, which is the middle number. So if we run this now, we should move around and it should decelerate to a stop when we release a key. And it does. Alright, nice. So if you release a key, it does not keep going in that direction. and I just formatted it using an extension. I'm going to add a gravity, so we're going to say if you're not on the floor, our velocity dot y minus equals our gravity times delta, but as you can see it gives us an error because the delta is of type double and our gravity is of type float, so we're just going to convert our delta into a float, and it does not give us an error anymore. Now to put in our jumping, we're going to say if is on floor and input dot is action just pressed, and we're going to say our jump action, and it has to be the same as what we defined in the editor. And we're going to say velocity dot y is our jump force. So when we run this, it should be able to jump. Yep. That is what we wanted. And that is on floor method is a built-in method to Godot. Now we should probably get some camera movement, as that's like the biggest thing of this tutorial. So we're going to use an override ready, which is a built-in function. And we're going to say our head is getNode of type node 3D. And then we put our path to the node relative to where the script is attached to. So if we go to player, our script is attached to player, and our path is head, so it's just head because it's relative to the player. This is equivalent to onReadyVar in GD script. This is because there is no onReady in C#. And we're going to set our cam to our camera. Oh, well, what is that? We're going to say it's head slash camera 3D, since that's what it is in the editor, and it has to be the same as the editor, which it is not because that D is capital. So there we go. Now we have our camera set to our camera variable. Next, we're going to make another override, and we're going to use the built-in function called input. And getting camera or mouse input using C# is a bit different from GD script, because we're going to have to say if event is input event mouse motion, we have to set this input event as a variable. So input event mouse motion mouse event, or mouse motion, sorry, that's what it auto corrected to. We're going to say it's event as input event mouse motion. So now we can reference this variable. And this part is quite similar to GD script. We're going to say head dot rotate y. We're going to say negative mouse motion dot relative dot x, which is the opposite of y, times our sensitivity. And see, we referenced that mouse motion variable. We're going to say cam. Actually, no. Let me just show you how this rotation works, because rotate y is like the opposite of our mouse x input. So if we try to rotate, it matches our mouse movement quite nicely. So now let's get the camera rotation so we can have horizontal and vertical movement. So cam.rotate x, negative mouse motion dot relative dot x, I mean y, sensitivity. So now we can rotate our camera vertically as well. And we use different rotation objects here because of the way game engines handle rotation. So you can see we can rotate vertically, but we can like spin around infinitely, so we need to clamp it. And this is also a bit different from GD script. So what we need to do is say vector 3 camera rotation equals camera dot rotation. Now we're going to say camera rotation dot x equals math f dot clamp our camera rotation dot x, and then we're gonna have to put in math f dot degrees to radians because we have to put, this is in radians, so we're going to convert the degrees, and we're going to say something like negative 80 for the minimum and 80 for the max. Oops, I accidentally put a 9 there. My parentheses. And to finally apply this rotation, we're going to say cam.rotation equals camera rotation, which is, and this is kind of similar to Unity. So now if we run this, it should work. And let's see what happens. Oh, that's not right. Oh my gosh. I set the two values to the same thing. So now if we do this, it should work properly, and we should not be able to spin around infinitely. And yes, it does work. So now we have our mouse movement. And just so our mouse isn't separate from our window, we can say input.mousemode equals input.mousemode enumerator dot captured. So it's just so we can like actually turn around and not leave the window. So as you can see, it's actually in the window now, so we can turn around properly. So to exit out of this, you can just press FN F8 or Command F8, but now you can see that the input doesn't match the way we're facing. And the fix for this is really simple. We just say head.global transform.basis. So we're just going to go by the head rotation instead of the player rotation. So the way we're facing is going to be forward, and it should work now. Yes. We go in the direction that we're facing, so that's very nice. And we can jump. Now I want to show you guys what happens if you tinker with the acceleration. So we're going to go back into our script. Now let's say our acceleration was something low, like 0.01. What this should do is it should take a really long time for us to come to a stop after we start moving. So, yep, we just kind of keep going, and it's slowing down. It just takes a long time. So if we were to change it to something like 0.1, it would take less time to slow down to a complete stop, but it would still be a noticeable amount of time for like a smooth stop or something. So it's not as instant. As you can see, once we release the key, it does kind of slow down to a stop. Now if you want super instant snappy motion, you just set the acceleration to the same thing as the speed, so it just stops instantly. And if we start here, it's really snappy, as you can see. And I'm sure if you tinker around with these, you could figure out something that feels nice. And that is it. We made a simple FPS controller with C#. Thank you for watching.